All right, welcome to The Explainer. Today, we're diving into something you probably never, ever think about, but it literally keeps our entire industrial world from grinding to a screeching halt. We're talking about lubrication. And believe me, it's a hidden story of microscopic battles with absolutely massive million-dollar consequences.
Okay, let's just kick things off with a statistic that is, well, it's pretty mind-blowing. Think about it. You're spending less than 0.5% of your budget on one thing, lubricants. But getting that one thing wrong can end up costing you 30% of your entire maintenance bill. That is a massive hidden problem and an even bigger opportunity.
And yeah, that brings us right to our first section. We're calling it the 30% problem. We're going to dig into the real, cascading costs of what happens when this seemingly simple thing goes wrong. So check this out. This is called the problem to failure curve, or PF curve, and it's basically the life story of a machine failure. Way over here on the left, in the proactive zone, that's when the defect first happens. Maybe a single tiny particle of dirt gets in the oil. As you move to the right, things get worse and worse until, bam, you hit catastrophic failure. Now here's the key. The earliest signs are totally invisible, but you can detect them with the right tools. By the time you can actually hear a weird noise or feel that something's hot, you are dangerously close to a total breakdown.
So here's the kicker. What if, instead of waiting for things to break, you went all the way back to that proactive zone and just eliminated the root cause? Well, the data's pretty clear. When you shift from being reactive to being proactive, you can extend the life of your equipment by 2 to 5 times. That's not a small change. That is a monumental gain.
But to get really proactive, we have to understand the microscopic war that's happening inside these machines. So let's zoom in and get into the fundamental science of it all.
And believe it or not, there's a whole field of science for this stuff. It's called tribology. It's the science of what happens when surfaces are moving against each other. It's not just about pouring oil on something to make it slippery. It's about managing friction and wear on a molecular level to keep our machines alive. A lubricant's number one job is to create a film, a tiny little cushion to separate metal surfaces. Now, there are 3 main types. The best case scenario is what you see here as hydrodynamic lubrication. That's where the parts are basically floating on a perfect film of oil. The worst case, that's boundary lubrication, where the surfaces are pretty much just smashing into each other, causing a ton of friction and wear.
So what's the deciding factor here? Well, it's a constant tug of war between speed and load. When speed is high and the load is low, it's pretty easy to create that beautiful, protective hydrodynamic film. But when the load gets really heavy or the speed drops, like when a machine is just starting up, that film can collapse. And that's when you're in trouble, with metal grinding directly on metal.
Okay, so how do we actually engineer a lubricant to win this battle against friction? Let's take a look under the hood, so to speak, and see what's actually in the oil.
You know, when you actually break it down, a lubricant is surprisingly simple. It's made of 2 main things, a base oil, which is most of the volume, and then a small but incredibly important package of chemical additives. And those additives are what give the oil its specific superpowers.
In that base oil, it's not all the same, not by a long shot. They're broken down into these different groups. Group I is your basic, cheap mineral oil. Move up to Group 2 and it gets more refined, more stable. And by the time you're at Group 4, you're talking about pure synthetics. They give you incredible performance, but they cost more and have different chemical properties.
But look, you can talk about all the different properties, all the fancy additives, but at the end of the day, one thing matters more than anything else, and that is viscosity. It's just the oil's resistance to flow, basically how thick or thin it is. It's what gives the oil the strength to keep those moving parts separated. Too thick, you have drag. Too thin, no protection. Getting it just right is everything.
All right, so we've got our hero, the perfectly engineered lubricant. But every hero needs a villain, right? Well, in this story, the number one villain, the number one cause of all these failures is contamination.
To really get this, we have to think on a scale that's almost impossible to imagine. We're talking about microns. A micron is 1/1,000,000th of a meter. To put that in perspective, a single human hair is about 70 microns wide. The particles that can absolutely destroy a multi-million-dollar machine are completely invisible.
Okay, so if these destructive little particles are invisible, how much of this microscopic dirt does it really take to bring down a massive piece of equipment?
You are not going to believe this. Get this. Just one single
teaspoon of dirt in a massive 55-gallon drum of oil is enough to contaminate it with about 1 billion harmful particles. Just 1 teaspoon. It's an incredible scale to think about. And those billion particles, they get to work inside the machine like liquid sandpaper. Sometimes a particle gets wedged between two surfaces and just grinds them away. That's 3-body abrasion. Other times, they create these tiny little stress points on a surface, which eventually grow into cracks and lead to total failure. Okay, so we've identified the bad guy, these tiny microscopic particles. Now, how do we fight back? How do we stop them before they can do any damage?
The solution isn't just one thing. It's a whole strategy, a 4-step battle plan. It starts with just storing and handling your oil correctly to keep it clean. Then you move to exclusion, using better seals and breathers to physically block dirt from getting in. And for anything that still sneaks past, the final step is removal, using really effective filters to keep that oil pristine. And this, right here, this is one of the biggest aha moments in this whole field. You'd think brand new oil is clean, right? Nope, it picks up all kinds of junk during transport and storage. In fact, new oil is almost never clean enough for critical equipment. You have to filter it before you even put it in the machine. All right, so all this microscopic attention to detail, all this talk about filters and microns, does it actually work in the real world? Does it save money? Oh yeah, let's look at the payoff.
Check this out. Here's a real case study from a steel mill. They put a proactive contamination plan in place. The result? Hydraulic failures dropped by an incredible 80%. Bearing failures were cut in half, and they used 80% less oil. I mean, those numbers are just staggering.
And how about this one? A large refinery was saving nearly $1 million a year, $935,000. And that wasn't from buying some new fancy oil. That was just from storing and handling the oil they already had in a cleaner, better way. That's it. And that really brings us to the big picture question, doesn't it? We've just seen how this hidden science can save a single factory millions of dollars. So what would happen if we applied this level of precision and care everywhere? To the car you drive, to the planes we fly in, to the power plants that light our cities. The science of the small doesn't just prevent failures, it unlocks a more efficient, more reliable, and more sustainable world, all starting with just one drop of clean oil.